Welcome to this explainer. We are constantly bombarded with these anxious headlines about robots coming for our jobs. But today, we're going to step back and calmly look at how AI actually changes the structure of human contribution. We're moving way beyond that tired humans versus machines debate to figure out what genuinely makes our roles durable in a world where execution is essentially free.
Here is our roadmap for today. We'll cover the wrong question, the uneven terrain, the energetic paradigm, defining and directing, trust and teaching, and finally, controlling the system. Let's dive right in. Section 1. The wrong question. Moving past job survival. To figure out what comes next, we really need to dismantle a super common anxiety about the future of work. When we see AI generating complex code or summarizing giant datasets in seconds, the immediate reaction is almost always, wait, is my job safe? We all naturally want to know if our specific profession is going to survive the next big software update, right? But honestly, framing it that way completely misses the mark. It's the wrong question to ask, because AI doesn't just sweep through and replace work evenly across the board. Instead, it attacks very specific energy structures. Think tasks with clear rewards, repeatable trials, and super cheap verification. Our human value isn't just a list of tasks you can cross off. It's deeply rooted in where society fundamentally allocates trust, authority, and real responsibility. So, humanity's durable role isn't protected by some vague sentimentality. It's not about humans just being warm while machines are cold. Our true moat is protected by structural functions. Things like defining what actually matters and holding the bag when things go wrong. These are functions that are simply too expensive or even impossible to fully automate. Section 2. The uneven terrain. Mapping AI capability. Once you stop hyper-focusing on job titles and start looking at the underlying tasks, a really fascinating map starts to emerge. AI capability isn't some smooth, flat frontier. It's a highly uneven terrain. On one hand, you've got high feedback zones, stuff like programming, mathematical proofs, and data retrieval. These scale incredibly fast because the AI gets immediate feedback and abundant examples. But then, on the other hand, you have low feedback zones, like defining brand new concepts, building genuine trust, or directing research. These areas require long, complex validation cycles and carry heavy social consequences, and that keeps them distinctly human. This distinction perfectly explains why so much highly polished AI writing still feels, well, kind of thin. AI models are great at using context to generate text based on probability, but they completely lack what we call a lived calibration converter. Basically, they do not bear the bodily, reputational, or social costs of the emotions they're describing. The critical bridge connecting lived experience to actual responsibility just isn't there. Section 3. The energetic paradigm, a systems approach. To truly understand these missing converters and analyze what humans actually bring to the table, we need a new framework. We call it the energetic paradigm, or EP for short. EP is a systems framework that treats human functions as analyzable structural mechanisms. So, instead of getting bogged down in philosophical debates about whether an AI has a soul, EP looks at intelligence as a series of energy flows, converters, constraints, and feedback loops. It's a grounded, logical way to map exactly where human cognition remains absolutely vital. When we look through the EP framework, we can map out intelligence across a few sequential steps. You go from gathering input to managing energy flow, passing that through a converter, like our lived experience, into a feedback loop, eventually hitting stability, and finally resulting in action. Laying it out this way makes it incredibly clear which steps AI can speed up and which steps still desperately require a human to anchor the whole system to real-world social consequences. Section 4. Defining and directing. The highest value cognitive objects. Let's apply this EP framework to our first uniquely human function, definition. While an AI might be an absolute genius at generating mathematical proofs to solve problems we've already identified, defining a completely new concept is a whole different ballgame. Under EP, a new definition is a powerful energy converter. You aren't just describing existing knowledge, you're reorganizing the entire space of what's possible, fundamentally changing which questions are even worth asking next. It's a similar story with research direction. AI is a spectacular tool for accelerating search and running experiments. But deciding on the direction of that research, that remains a strictly high-level human function. And why is that? Because it requires identifying important uncertainties, selecting which problems are actually valuable to society, and understanding the real-world fallout of those tests. AI can run the experiment all day long, sure, but humans have to allocate the collective effort to decide where to look in the first place. Section 5. Trust and teaching, infrastructure, and state control. Now let's look at two deeply social mechanisms that get misunderstood all the time. First up is trust. Trust is not just a warm, fuzzy feeling. It is critical social energy infrastructure. Look at all these layers: motive, calibration, responsibility. True trust requires real reputational risk. It demands accountability and the capacity to bear the consequences when things inevitably go wrong. An AI can mimic the signals of trust flawlessly. It can sound super confident or even humble, but it cannot bear the actual infrastructure costs of trust. And that exact same logic applies to teaching. Education is so much more than just a simple transfer of facts from teacher to student. I mean, if it were just data transfer, AI would have replaced teachers years ago. But teaching is fundamentally about cognitive control. It's about maintaining a learner's motivation, sniffing out hidden misunderstandings, and guiding their mental state so that learning becomes stable and permanent, rather than just a temporary performance. Section 6. Controlling the system, aligning capability with value. The really crucial point here is how we actually manage these incredibly powerful computational tools. Control should absolutely never be viewed as just a safety restriction you slap on at the very end of a project. In the energetic paradigm, control is woven deep into the intelligence process itself. Whether we're talking about objective control, which defines what the system is actually trying to optimize, or boundary and feedback controls, these are the mechanisms that keep raw, unbridled computational power firmly tethered to actual human value. To tie this all together today, this really captures our ultimate message. Yes, AI is massively reducing the cost of execution, generation, and retrieval. It's practically making it free. But instead of replacing us, it's shifting where our structural importance lies. The core of human value is relocating. It's moving toward defining what holds value, establishing that crucial infrastructure of trust, picking the right directions for research, and maintaining control over these powerful systems. Which leaves us with a critical thought to ponder. We're crossing the threshold into an era where execution, the actual tedious generation of code, text, and answers, is basically free. So what I want you to take away from this explainer is this question. Now that execution is incredibly cheap, how will you adapt your own human workflows to focus on defining what truly matters? Thanks for joining me today.